Today we're going to look at the section over binomial theorem. What the binomial theorem helps you do is if you have some expression, let's just say, get my pen here, let's just say that you have something like x plus y to the fifth power, and you want to multiply that out. You do x plus y times x plus y, so on, so on, so on, to do that 5 times, and it gets to be this long, big thing. Well, the binomial theorem, since this is a binomial, two terms, we can use this to help us do this in a much easier way instead of spending all that time multiplying it out. So it gives you this long, complicated thing here, and it's just telling you that the number in front, the coefficient here, it can be figured out by using this formula right here. It says NCR is equal to n factorial divided by n minus r factorial r factorial. And this notation right here and this notation right here mean the exact same thing. Okay? So let's get some practice doing this NCR. And later on we'll call it a combination, but right now we'll just call it NCR here. Let's get some practice with that so we can get better with that before we move on to actually expanding these things out. Okay? So it says determine the binomial coefficient 10C4. And what that is saying is if we follow that definition, that would be 10 factorial divided by 10 minus 4 factorial, which is 6 factorial, times 4 factorial. Remember, I'm going to write this one out this time, but I'm not going to write them all out. So 10 factorial is 1 times 2 times 3 times 4, 7, 8, 9, and 10. Again, I'm not going to do this every time because it takes way too long. But we'll just do the first one to make sure we remember what is going on here. We have like that. Okay, so 1, 2, 3, 4, 5, 6 reduces with 1, 2, 3, 4, 5, 6. Let's see, 2 times 4 is 8, and 3 goes into 9 3 times. So when I simplify all that stuff, everything in the denominator cancels out. 7 times 3 times 10 is 210 would be that answer. Okay. Now 6 and 2, remember that's the same thing as 6C2. If we follow the definition, that would be 6 factorial. 6 minus 2 is 4 factorial times 2 factorial. And that goes to, and what I'm going to do, I'm just going to do, let's do it this way. 1 through 4 factorial times 5 factorial, 6 factorial. Hopefully that notation is okay with you, because that, right, messed that thing up, didn't I? It's not factorial there. Let's try it again. 4 factorial, 5 times 6. Okay? Because 6 factorial would be 1, 2, 3, 4, 5, 6. So 1 through 4, and then 5 and 6. And then 1 times 2. So these guys wipe each other out. And then 2 goes into 6 3 times, so that gives you a grand total of 15. Okay? I don't like to write it all out like that every single time, so that's why I just kind of do something like that. Or you'll see here in a second another way that I can do it. 7C7, 7 factorial. 7 minus 7 is 0 factorial. And 7 factorial. Well, obviously, the 7 factorial and 7 factorial reduce each other out. So 1 and 1. And remember, 0 factorial is not 0, like a lot of people think. It's 1. So 1 over 1 just goes to 1. Okay? There's some special cases that we're hopefully going to see, and when the numbers are the same like that, it's always equal to 1. That's one of the special cases. Let's go on to 5C1. Here's another one of those special cases. That's going to be 5 factorial. 5 minus 1 factorial is 4 factorial, and 1 factorial. Obviously the 1 factorial is just 1, but 5 factorial is really 4 factorial times 5, or 4 factorial, and obviously, let's change the color here, the 4 factorials wipe each other out, and all you're left with is 5. So here's another special case of if it's 5C1 or any number C1, everything's going to cancel out except for that number, which is on this case 5. Okay. 10(9), remember that's the same thing as 10C9. which is 10 factorial, over 10 minus 1 is 1, and 9 factorial. Very similar thing what we had here. 5 and 1, and then these numbers that are just 1 off of each other like that are going to give you the same result, because that is really 9 factorial times 10 over 9 factorial. Of course, the factorials wipe each other out, and we're just left with the grand total of 10. Okay, so as you do more and more of these things like this, you're going to see some special cases that if you remember how to do it, save you some time. If not, you can go ahead and work it out. That combination thing there to figure out what the coefficients. But to me, an easier way of doing that, instead of doing it the long way there, is using Pascal's Triangle. And Pascal's Triangle, hopefully you've seen this before. What it is every leading number there, every starting number is 1, and every ending number is 1. Okay? This is really called row 0. This is called row 1. This is called row 2. This is called row 3, because whatever that second number is what row it is. Okay? And that's going to match up with our exponents. This would match up with like x plus y to the first, x plus y to the second power, and cubed, and so on and so on. But the way Pascal's triangle is figured out is, remember I said it always starts and ends with a 1. And this number right here is determined, you add these two guys together right here, and that is that number right there. So 1 and 3 is 4, 3 and 3 is 6, 3 and 1 is 4. And this goes on 4 and 1, 4 and 6, 6 and 4, 4 and 1, and 1. And this pattern just goes on forever and ever, as long as you need to make it to be able to get to whatever row that you need to help you do this. Okay? And this is going to help us, and we're going to use Pascal's triangle here in this next example. Let's just go to that, so you can see how Pascal's triangle will help us. Okay? I'm going to write out Pascal's triangle over here for the fourth row. 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Okay? Now, pay attention here. What we're going to do is write those coefficients out. 1, 4, 6, 4, 1. The sign is positive, so every single sign is going to be a positive with those guys. Okay? Now, what we do is we take the first term, x here, x to the fourth power. It always matches up, and then we just go in decreasing order down the line there. So x to the fourth, x cubed, x squared, and x. Now, we do a similar thing, but with the number, the second term, the number in the back side of that. We start in the back and go backwards. So that'd be y to the fourth, y cubed. Again, we use every single power. Y squared, y, and then no y's there. Okay? And then all you do at this point is just simplify. And thankfully, it's already simplified. We don't have to do anything else there. It's just, if you want to rewrite it without the 1's in it, you could. And you have your answer, something like this. Okay? So let's use that same thing for the fifth row. Now, we only went to the fourth row here, so I'm going to add the fifth row so we have it to look at. Okay? Same concept here. 1, 5, 10, 10, 5, and 1. Plus sign, so everything is a plus again. And we'll get to the minus here in a second. Now, we'll start with the first term. Let me change my color here so we have something different. 2x. Now, 2x to the fifth, 2x to the fourth. I'm putting in parentheses because it's the 2 and the x that's going to get that exponent, not just the x. So 2x squared, 2x. And the other guy, the last term there, is 3y, so it starts on the back side. 3y to the fifth. Didn't leave myself enough room here, but you can get the idea. 3y to the fourth, 3y cubed, 3y squared, and 3y. Okay. So 2 to the 5th would give you 32, x to the 5th. 2 to the 4th times 3 times 5 would give you 240, x to the 4th, y. 10 times 2 cubed times 3 squared would give you 720, x cubed, y squared. 10 times 2 squared times 3 cubed would give you a nice big number of 1080, x squared, y cubed. This guy simplified would give you 810, x, y to the 4th. And the last guy there would give you 243, y to the 5th. Now, this to me is a whole lot easier than using the NCR, and extremely much easier than doing just multiplying all the way out. So let's go to our next two here. We have, let me rewrite my my Pascal's Triangle, not Pythagorean Theorem like I almost said there. So that is our Pascal's Triangle. 1, 3, 3, 1. Now the difference here is we have a negative. Okay, when you have a negative, the first one's always positive, but then it alternates: positive, negative, positive, negative. It's always going to do that if it's a negative sign. So now we just follow that same rule that we had. The first term is x to the 3rd power, x squared, and x. The last one, 2y. Don't do the negative, just do the number that's there. 2y cubed, 2y squared, and 2y. Okay, so when we simplify there, obviously we just have x cubed there. 3 times 2 would give us 6x squared y. 3 and 4 would give us 12xy squared. And 2 cubed, of course, is 8. So there is that thing all multiplied out. Now you'd get the same thing if you did x minus 2y times x minus 2y times x minus 2y, but now that would take you much longer and a much easier way of messing things up as opposed to just doing it this way. And I think the Pascal's Triangle is the easiest way of doing that. Okay, so let's just do one more quick one. 4x minus 5 to the cubed. So again, same numbers with the Pascal's Triangle. Just giving you one more practice with that. It's a negative, so it's a positive, negative, positive, negative. The first term is 4x, so that's 4x cubed, 4x squared, and 4x. The last term is 5, so that's 5 cubed, 5 squared, and 5. And when we simplify, 4 cubed is 64. 3 times 16 times 5 would give us a total of 240x squared. That mess there goes to 300x. And 5 cubed would give us 125. Now we look at example number 3. It says find the 5th term of this binomial here. Now you could use Pascal's Triangle and go through the whole thing, go down to row number 9, go all the way to your 5th term and figure that out. But that's kind of a long way of doing this one. Here's where it comes in handy using that NCR thing. So if we go back and look at the box that's there at the front of the notes, it says NCR x to the n minus r times y to the r would give you one specific term. Okay, and this is the r plus 1th term. Okay, so what we have to figure out is we're trying to find the 5th term. So this r plus 1 is equal to 5, so my r value is going to be equal to 4. Okay, and the exponent, whatever the exponent is that you're taking, that's always equal to your n. So what we have there, if I'm plugging all these numbers into the formula that we have, n CR. Now x and y just refer to the first term and the second term. So the x piece is really the 2x here. So that would be put in parentheses so you don't get yourself messed up. N minus r, 9 minus 4 is 5. and y is the second piece, which when you're doing this, I would go ahead and put in the negative sign so you don't get yourself messed up there. Since we're only finding one term, we want to make sure we have the right sign. So negative 3y to the r power, just like that. Okay, so simplify things out. Now, you can work this out. There's also a way of doing it on your calculator. If you can figure that out, good. I don't have that calculator with me right now to be able to do that, but you can do that. If you work that out, you get 126, okay, for NC4. And 2x to the fifth goes to 32x to the fifth. And a negative 3y to the fourth gives you 81, y to the fourth. And of course, we multiply all that mess together, and you get the brand spanking big term of x to the fifth, y to the fourth. So 326,592 x to the fifth, y to the fourth would be that one term. Now, there's no need to use Pascal's Triangle to figure all those terms out, since all we need is that one. Okay, now we're going to look at the last example, example number 4. It says find the coefficient of the term x cubed y to the fifth and the expansion of that. So it doesn't tell us exactly what term we need, but if you remember how we use the NCR, x to the n minus r and y to the r, we know that if we match it up with this right here, we know that right there is going to be our r value, right? So r is going to be 5. And this number right here is always n minus r. So 8 minus 5 will give you 3, or 3 plus 5 is 8. These two numbers added together always have to be the n value. So I know my n value is 8. Okay, so let's plug those things in and see what we get. 8c5. The first term is 4x. 8 minus 5 is 3. The second term is 3y to the r, which is to the fifth power. 8c5 is 56. 64x cubed and 243 y to the fifth. If you multiply those up, you get 870,912 x cubed y to the fifth. Now, doesn't ask for what's the whole answer. It says what is the coefficient. So the coefficient is just 870,912. So hopefully this has helped you come up with some shortcuts on how to expand these things out without actually having to multiply it all out and take forever.